Let's go over 3 truth tables that cover all the main points you would need to know. First of all, let's take just a complicated statement here and let's break it apart piece by piece. So when we're constructing a truth value table, we need to look first what variables we have. Here we have a P and a Q, so we have 2 different variables. And then we need to write every possible combination of true and false for those 2 variables. So we could have P true, Q true, you could have P true, Q false, P false, Q true, or P false, Q false. Those are the only 4 options you would ever have. And you need to set up those 2 columns first before you can really jump in. Now, we could try to go straight after this entire thing, but I would have a lot of problems doing that. So what I like to do is break it apart little piece by little piece. And there's no exact right way to do this. There's many right ways to do it. I like to start with parentheses. So I might make this the column of a header here, except the problem there is I would be looking at P and not Q, and I don't have a column yet for not Q. So what I'm going to do before I tackle that entire parentheses is I'm going to make a column for not Q. And when I have any column that starts with a negation here, a not sign, I'm just going to find this column and do everything completely the opposite. So in this case it's not Q, I'm looking for a column Q. If I wouldn't find that, then that's probably what I should create before I try to get the opposite of it. But in this case I do have column Q here. So this not Q should be the exact opposite, meaning I should go false, true, false, true. Now that I have that not Q column, I can tackle this entire parenthesis because I'm looking at the 2 sides of this and. This is a conjunction, but it's basically functioning like an and. So I should find a column labeled P, which I do right here, and I should find a column labeled not Q. If I wouldn't find one of those columns, then I should create it before attempting this that puts the 2 together. So now that I've identified this column and this column, what does that and sign mean? Well, what it means is both the left side has to be true and the right side has to be true in order for this column to be true. So here, for example, I have a true on the P but a false on the not Q. So that's going to be a false. Over here, I have a true on the left side, a true on the right side of this and sign. So since I have both, that would be a true. Here's a big mistake right here that people often make. Notice this row has a false for P and a false for not Q. So in other words, it has the same value for both of them, but that's not going to cut it. In order to make an and sign, you have to have both of them be true. So even though they're the same value, that value isn't true. So I'm going to put a false, and here I have a false and a true, so that's also going to be false. So to summarize again, if you're looking for an and, if you find a false in either this, or in both, then that particular row is going to be false. The only way to get a true in a column with and is if both of these values are true. Okay, now we've got this entire parentheses part. We could go after the whole thing right away, but we would notice that even though we have a column for the left side of this or symbol, we don't have a column yet for not P. So let's create that first. And again here, I'm just looking at the column entitled P, and because it's a not sign, I'm going to go everything the opposite. Everything the opposite value of what it was in this P column. Okay, now I've got everything I need for my final statement. Let me stretch that over there. So notice I have this column right here, and I have this column right here. So now I just need to interpret what this or means. Well, this column here is going to be true if at least one of these two is true. Remember, here I had to have both sides true. Here, if the left side's true, I'm okay. If the right side's true, I'm okay. If both of them are true, I'm okay. I need to have at least one true. So if I look at this first row, I have a false for my left side and a false for my right. So I didn't get at least one true. That's going to be a false. Here, I do have a true. Doesn't matter that this is a false. Here, I have a true. And here, I also have a true. So the final value, truth value here, for this particular statement, essentially what it does is it gives me whether or not this entire statement is true or false based on what my initial conditions were. So if P was a statement like Daniel is a billionaire, so that's a false statement, and Q was a statement like EMU is a liberal arts university. That's a true statement, right? So in order to find the value of this whole big mess, I would need to go where P is false and Q is true. That statement that I'm a billionaire is false. The statement that EMU is a Christian university or a liberal arts university is true. So I would look all the way over here. In that certain situation, this entire statement would be true. So I can pretty quickly look at the value of that complicated statement just by knowing whether P is true and whether Q is true. Okay, let's go on to the next question here, which would give you two statements and say, are these two things logically equivalent? Another way of saying that is, if you would chart this particular statement in the table and chart this statement in the table, would their truth values line up on every single row? So if this one was true, false, true, true, then this one should also be true, false, true, true. If there's one place where they don't agree, then they're not logically equivalent. In order to be logically equivalent, they must have the same truth value on every row. So in order to tell that, of course, we need to plot this. So let's go ahead and set the truth table up like we did before. Okay, and again, we could try to get this immediately, but let's break it down. Let's get the not Q first. So we're just searching for that column Q, then we're taking all the opposites. And now let's get that P and not Q. So we find the P column right here, and we find the not Q column right here. And in order to get and, we need to see a true in both of those. So here we have a false on the first one. Here we do have a true on both of them. False, false. Again, if both of those values would be false, that's still a false. The only way to get a true and is if both the first and the second are true. Now let's get this negation. So since we already have a column for this entire thing, all that the negation does is tell us to take the opposite of that column. So in this case, I would go true, false, true, true. Just taking the opposite value for each of those. Okay, so now I've got the first statement all plotted out. Now I need to do the second one. In order to get that, it'd be nice to have a column for not P. Okay, so I'm looking for the column P, and I'm going to reverse all those values. And now I can set up this. So I'm looking for the column Q and the column not P. So here's my column Q, here's my column not P. In order to be an OR, I hope I said OR before if I said this. So in order to get an OR, I need at least one true. Well, in the first row, I have a true there, so I'm good. On the second row, I have false and false, so that's false. On the third row, I have a true right there. I don't even need to look at the Q, even though that is a true. And on this fourth one, I have a true here also. So when we ask if they're logically equivalent, we're looking at this row and, sorry, that column and this column. Do the truth values match up on every row? Well, you can see they do. True, true, false, false, true, true, false, false. So we would say that yes, the two values are logically equivalent. Okay, and let's look at what a truth table would look like for an implication. So go ahead and fill out your P and Q. Okay, and let's go through just like we have. See if you can get everything except this sign based on what we've done before. Pause the video and try that, and then come take a look at what we have. Okay, these would be the 3 column headers. This is an AND statement, so I need both of them to be true. This is the first row is the only place where that would happen. The P and Q are both true. Then we need the opposite of P and Q. Well, since we already did the P and Q column, all we have to do now is take the reverse of everything. So that reverses each of these values. And then the not Q would look like that, reversing the values of this Q column. Okay, so finally, we're ready now to do the implication, but how exactly does that work? So since we have this column here on the left side and this column on the right side, we can evaluate the implication. The only time this will ever be false is if the first part, the left side of the arrow, is true and the right side is false. We can think of this like a broken promise. So if you do this, then this will happen. Well, they did this and this didn't happen. That's a broken promise. So we're looking for any place where this column is true and this column is false. Let's see where we have that. There's a false, false, true, 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 false. This is the only place where we see a true, false. So that's a false. That's a broken promise. The rest here are true. It's worth talking just real briefly about why this one is true. So if you have something false over here and you have something false over here, why is that a true statement? That's what's called vacuously true. In other words, I might make a statement like, if you are Superman, then I will give you $1 million. Well, you're not Superman, and I didn't give you $1 million, but because I didn't really break my promise, you didn't even keep your end of the deal, you weren't Superman, Superwoman, it was never really, the promise I made you was never put to the test, and so we put a true here. Essentially, you only put a false here if it's a broken promise. If this thing is true and this thing is false, that would be the only time that you put a false.